My name is Raza, and I'm the CEO of Fiber Mountain Incorporated. Fiber Mountain is a young company located in Connecticut on the East Coast. If we look at today's environment, our networks are changing in very different ways, and Fiber Mountain leads a change in the infrastructure of data centers. So if we look at our daily lives, our business lives, and our personal lives, we have a lot of applications, a lot of bandwidth-hungry applications, a lot of mobile devices that we work with. All of the data and the packets that are generated by these mobile devices and applications is really going somewhere, and data centers is where some or most of the packets come into. Data center networks are growing tremendously because of the bandwidth needs as they grow. Now, as more and more data centers are put in place, and we see that the numbers of data centers grow, as well as each data center grows in size. You increase the switches there, the servers, and all of the equipment. Increase in equipment comes with more power consumption, more heat dissipation, more space usage, and Fiber Mountain looks at this phenomenon and says, our bandwidth requirements are not going to reduce. However, we do not have infinite power. We do not have infinite space. We have to do everything we do. We have to allow the growth in our data center networks and our mobile and devices and applications, but we have to do it more efficiently. And so Fiber Mountain created a methodology and an architecture where you will need fewer switches, more expensive switches, and when you have fewer of them in the network, and yet you can scale and grow to the requirements that grow to the needs of our applications. You will have less power consumption, you will have less heat generation, and at the end of the day, it's just a simple network that can grow immensely, and it's entirely software controlled. So we do build software and hardware, but in our architecture, the hardware is going to be reduced as we move forward, and more software will control the network. And it's easier to manage, it's easier to control, it's easier to scale. And we're out here at Interop showing the world how this new architecture works and it scales. Fiber Mountain talks about the glass core. Our glass core network is a simplified network that enables immense scalability. And I want to share with you what we do in this, in the hardware and the software through our demonstrations here. So what we have are switches and optical cross connects. And these switches and optical cross connects have very high density fiber optic cabling in them. And what that allows us to do is to move or change from 1 gigabit, 10 gigabit per second, 40 gigabit per second, 100 gig per second traffic without sending any human beings in the data center. In other words, if you wanted to move from 10 gig to 40 gig, previously you had to send a technician in to remove the 10 gig cable and install the 40 gig cable and install 40 gig switches. Today, Fiber Mountain can do that, perform that job all via software, all in a matter of seconds. You do not have to change the cable because these high density fiber optic cables have a lot of fiber strands in them, and to us the strands are a resource controlled by software, and we can use and move them. Furthermore, one of the things we do is out here you see a screen with a planning tool. We allow a customer to plan their network, their data center network, whether they're building one rack or one row, and it's very easy to take devices or things in a list here and move them and dynamically have a 3D drawing of what you're going to deploy. Once you've done that, you hit a button here, it drops a bill of materials, you can order the stuff. Another button gives you the installation guide, and you can install the network in that one. If you install the way we tell you, you will not send any human beings into the data center because we can actually move the physical layer and give you any type of connectivity you like. Then on top of that, our glass core infrastructure has what we call PLPs, or programmable light paths. We can create a programmable light path from one port, a server port for example, to another server port, storage port, or switch port, all via software. Furthermore, where we are really headed is there's a lot of change in our servers and switches that's happening because of software-defined networking. We look at servers and say, with innovations in server technology, you will see multi-port interfaces on servers. What we would like to say is, a server, 80% of the traffic from a server is going to a few destinations, maybe 20 or 40 destinations. Storage A, storage B, storage C, cluster A, server C, D, and F. If we can take these elephant flows and direct them over a very fast glass core network, extremely low latency, and it's low latency because we really don't have many hops of switches. We propose that the glass core does not have large core switches in it. We process at the edge and use fiber optic connectivity that's changeable via our software, and these programmable light paths in the glass core to give you an extremely fluid, extremely efficient network at your fingertips. And with this, what we have out here is really a demonstration of our intelligent cabling, our optical cross-connect that can really transfer light in the core of the network from one port to another, as well as our switching capability and what we've done for network switching. We have, when we allow you to reconfigure the physical infrastructure and the connectivity so fluidly and dynamically, we also have to take care of certain things, certain issues in the network, such as spanning tree. In our networks, you can put multiple 10, 40, or 100 gig links between the same two devices or same two switches for that matter, and you do not have to turn ports off or links off for spanning tree. We deal with that. We have enhanced VLAN functionality, multi-chassis LAC functionality. We can go from a server to many switches or destinations. We're enhancing networking, and as I say, we're enhancing networking. We're really enhancing it by